Okay, so photometric stereo is used in a couple of interesting applications. It does have some challenges, like you have to know the reflectance function. You have to know that reflectance map. So typically it's assumed for Lambertian types of stuff, maybe a little bit of specularity, but basically you have to understand the reflectance function. It also has a problem with shadows or inner reflections because it's assuming that the only thing that matters was the orientation of the surface with respect to the light. There are some smaller problems, like the cameras and light sources have to be far enough away that it's a constant angle. That's not so bad. Calibration is important, right? Remember, we're assuming that everything is linear in terms of the intensity with respect to the light that's hitting the camera. So you need a lot of photometric calibration. Before I conclude, a couple things about some shape from shading. One is there was a really cool use of it. There was a paper, actually won one of the Marr Prizes in 1995 in ICCV, and it was this idea. The name of it is Shape from Shading with Inner Reflections under a Proximal Light Source, Distortion-Free Copying of an Unfolded Book. And it appeared later in IJCV, International Journal of Computer Vision, and what they were looking at was this idea that, you know, when you put a book down on a scanner or a copier, you get this surface that bends away. And you can recover something about that surface structure, and you should also be able to sort of unshade what happens because the light falls off. Now, unfortunately, the images that are in the original picture don't reproduce very well, so you're going to see something that looks really ugly here. Obviously, it wasn't pure black in here, but it was just very darkened, and they were able to recover the white in the text by essentially undoing the shape from shading. And I thought that was pretty cool. Shape from shading also, in the human world, of course, is much more complicated, a whole bunch of interesting effects. One that's well known is this light source direction effect. So if you see here on the right, you probably see, especially if you're looking at this sort of vertically, you probably see a sphere lit from up here. What most people see, if you show them just this thing on the right, is a dimple, something pushed in, okay? With, again, the light source coming down. Now, of course, figure B is just figure A rotated around. So on one, you see something bent out towards you. On the other, you see something pushed in. But the reality is they've just been rotated around. There seems to be a human preference for light sources to be up above instead of down below. And there's a whole bunch of other work on sort of human effect. There is another demonstration of human shape from shading, which is a multi-billion-dollar industry. And that's called makeup. So and there's no way to say this without being gender specific, so I will say it. As many women know, properly applied foundation can cause the shape of your cheekbones and other parts of your face and other elements to be perceived as having either a higher shape or more rounded. And what you're doing is you're changing the shading just a little bit so that the human vision system ascribes a slightly different shape to the underlying contour. And so it's taking advantage of shape from shading. And you know, good makeup artists know exactly how that works, and that's an interesting shading phenomenon.